Today, we'll finish it tomorrow. What we're talking about today is division, polynomial, synthetic, and long division. Now, this isn't anything new. We've done this before. We did this in Algebra 2. And what we're going to start off and talk about first is long division, dividing two functions with long division. Now, if you notice that a 0 of f occurs at x equals 2, as shown on the graph here. Because x equals 2 is a 0 of f, you know that x minus 2 is a factor. Because if it's a factor, it's a 0. It's a solution, it is a factor. So x equals 2 is a solution. So if we subtract 2 from both sides, we get that x minus 2 is equal to 0, so it is a factor. That means there exists a second degree polynomial function q of x such that x minus 2 times that there will give us our original equation. Essentially, all this is saying is that if we know what one of the factors is, one of the solutions, we can use it with division to find the rest. So if we wanted to divide this here, 6x cubed minus 19x squared plus 16x minus 4 by x minus 2, we can find our other solutions. I don't know if y'all want these.
May I have your attention? May I have your digit please? We have the following students come to Ms. Bruckner's room: Levi Dale, Jordan Berry, Brooklyn Wittenmeyer, and London Farmer. Thank you and have a good day.
So with long division, we set our problem up. We'll put the 6x cubed minus 19x squared plus 16x minus 4 inside, x minus 2 outside. Now, whenever we do division, either long division or synthetic division, we'll decrease the degree. So here our starting degree is degree 3. So since x cubed, we're dividing it by degree 1, x to the first. So our solution should be x squared, degree 2. Now, the first step in long division is trying to get this first term and each of the expressions become 0. So we need to see what we need to multiply x by to get 6x cubed. Well, our number in front of x out here is 1. So what do we multiply 1 by to get 6? Well, 6. And what do we need to multiply x by to get x squared? Oh, sorry, not x squared, x cubed. What do we multiply x by to get x cubed? Well, it would be x squared, because the goal is to get this first term down here to be 6x cubed. And that's where we get the 6x squared from. So we can multiply first. So we're going to do 6x squared times our x minus 2. 6x squared times x is going to give us the 6x cubed we want. And 6x squared times negative 2 will give us negative 12x squared. And then y'all will need to make sure you check in. Now at this point here, question on this here before we move on to the next step. We're going to subtract. 6x cubed minus 6x cubed is 0. Because again, we want this first term, our x cubed term, to become 0 first. We'll subtract the rest. Negative 19x squared minus negative 12x squared. Negative and negative makes a plus. So negative 19 plus 12 would be negative 17x squared. So that finishes the first main step. At this point here, we'll bring the next term down and repeat the process. So now we need to see what times our x is going to give us negative 7x squared. Well, for starters, we'll need negative 7. And then what times x gives us x squared? Well, that'd be 7, negative 7x. And we'll multiply again. We're going to say negative 7x times our x minus 2. Well, negative 7x times x would be negative 7x squared. And negative 7x times negative 2. The negative make it positive, and 7x times 2 would be plus 14x. And we'll put it underneath this here. And again, like before, we're going to subtract. Now, negative 7x squared minus negative 7x squared, this will be 0, just like before. This will cancel out. 16x minus 14x will be positive 2x. And lastly, we bring down the final, minus 4. Last step, what times x is 2x? It would be positive 2. And we do this one more time. We're going to say 2 times x minus 2. 2 times x will give us 2x. 2 times negative 2 would give us negative 4. And last but not least, we're going to subtract. Now our 2x minus 2x would be 0. Our negative 4 minus 4 also works out to be 0. So what that tells us is that we do have a remainder of 0. And our solution after dividing is 6x squared plus 7x plus 2. Questions on how we got to this here? And what this is also telling us is that our starting polynomial, our 6x cubed minus 19x squared plus 16x minus 4, is the same as x minus 2 times our 6x squared minus 7x plus 2. These are the same exact expressions. And this is nice because trying and looking at 6x cubed minus 19x squared plus 16x minus 4 might not have been as easy to factor. Knowing that one of the factors was x minus 2 is going to help us be able to factor the rest of it. There's now, if we want to factor the rest of this expression, the 6x squared minus 7x plus 2, we can. Since the 2 is positive, our signs are the same and match the sign of the middle term, so negative and negative. Factors of 6x squared, well, we'll have x and x. Now 6 is either going to be 1 and 6 or 2 and 3. We can try 2 and 3 first. Only factors of 2 are 1 and 2. So I'll plug those in, and the last thing we can do just to make sure is we can check this here. 2x times negative 2 would be negative 4x. 1 times 3x, negative 1 times 3x would be negative 3x, giving us the negative 7x middle term. So it actually turns out that x minus 2 times 2x minus 1 times 3x minus 2 are all the factors for this here. So we're able to divide this by x minus 2 and then use the result to factor it all the way down. And that's what they did here. So they do a dividing step. Look at this here, and then we can conclude, just as we said, x minus 2 times 6x squared minus 7x plus 2. Factor it to get this polynomial down to a completely factored form. In example 1, x minus 2 is a factor. This here is the long division process produces a remainder of 0. Often we have a non-zero, because if it doesn't give us a 0 as our remainder, it means it's not a factor, it's not a solution. So here we can do the same thing. Now we need to get our first term that we're multiplying. Now, we could do the divide step, or we can actually take from what they did. To get the first term or each term, we take the first term in the expression and divide it by the first term in the expression outside. So when we look at this here, the first term in the expression for this here is x squared. Our first term in our expression outside is x. So another way we can get this first term is we can start off by x squared divided by x, which is just x. So the first term we're going to multiply through in our division step is going to be x. So we'll start off with taking that x and multiplying it by our x plus 1. Well, our x times x is x squared. X times 1 is plus x. We can line it up under our expression, and just like before, we're going to subtract. So our x squared minus x squared would be 0, just like we wanted. 3x minus x is going to give us 2x. And then we'll bring down our plus 5. Now we need to figure out our next term, and just like what we can do is we can take the first term in the expression that we have, divide it by the first term in our expression outside. So we'd say 2x divided by x. The x's will simplify out, leaving us with a positive 2. So the next thing we need to multiply through by is 2. And then we distribute this 2. 2 times x will give us 2x. 2 times 1 will give us 2. Last but not least, we'll subtract. 2x minus 2x cancels. 5 minus 2 gives us 3. Now, since we do have a remainder, we have to add it back in as the remainder over what we were dividing the polynomial by. So this ends up giving us x plus 2 plus 3 over x plus 1. So our dividend and divisor gives us our quotient and the remainder. Now if we multiplied it back through by our x plus 1, we would get back to the original expression. If f of x and d of x are polynomial functions, that d of x is not equal to 0, and the degree of the d of x is less than or equal to the degree of f of x, what we started with, then there exists unique polynomials q and r such that this is true, where r of x is equal to 0 or the degree of r of x is less than the degree of d of x. If the remainder r of x is 0, d of x divides evenly. Just a lot of explanation for the fact that f of x, if we divide it by something, we'll have our division and our quotient plus our remainder. In more of a non-fractional form. Essentially what they're saying is we can take any division problem and rewrite it in this form here as a product of its factors. Or we can write in this way here where we have our whole part and the remainder divided by what we're dividing this by, or an improper. Before you apply the division algorithm, follow the steps, and we can get there. There's a nice shortcut for long division of polynomials by divisors of the form of k minus x. The shortcut is called synthetic division, and we've done this before because we have our setup and multiply and add. So when we have synthetic division, The way we set synthetic division up is that we have the cubby and our line. Now to find the number or terms that go in the cubby is we take what we're dividing it by, x plus 3, and set it equal to 0, and solve for x. Now here we're just going to subtract 3, telling us that x is equal to -3. We take that and plug it in. Really, we're just getting whatever variable has the biggest degree and getting it by itself. So here x is the term with the biggest degree, so we get it by itself. Now the numbers going across the top are going to be our coefficients of our quotient, or our, our dividend. Quotient is what we finished with. Our dividend here. So the number in front of x to the fourth would be 1. We do not have an x cubed term, because anytime we have a missing term, we'll fill it in with 0. X squared will be -10. X will be -2. And our constant term is 4. And at this point here, we bring the first number down. Questions on how we set this up? Now we're going to start the process with multiplying. So we'll do -3 times 1, which is -3. Add straight down. 0 plus -3 is, well, -3. Then we'll multiply again. -3 times -3 would be +9. Add straight down. -10 plus 9 is going to be -1. -3 times -1 is +3. We add straight down. -2 plus 3 is 1. -3 times 1 is -3. And lastly, 4 plus -3 would be 1. The last number under the line is the remainder. So all that's telling us is that our divisor, x plus 3, does not divide evenly into our dividend because we do have a remainder other than 0. Now we do have to put the variables back in. Now the last number here is going to be the remainder. The number in front of it is our constant term. The number in front of it is our term with x, x squared, x cubed, because x is going to increase by 1 in each degree. Also, our divisor's degree is 1. Our dividend's degree is 4. So our quotient degree should be 4 minus 1, or 3. And what that tells us is that the result that we have is x cubed minus 3x squared minus x plus 1 plus our remainder, which is 1, over our divisor, which is x plus 3. Questions on this here? And as we look at this here, so they have a little bit different way they set the numbers up, but the process remains the same. Remainder in the factor theorem. We'll finish this tomorrow.